Find f of negative 3 for this piecewise function. So I'm going to check these domains, and I'm going to see negative 3 where it fits. Negative 3 is not less than negative 4, so I'm not going to use this one. Negative 3 is between negative 4 and 13, so I know to use 6 minus x squared. 6 minus negative 3 squared, and that's 6 minus 9, which is negative 3. In 14, it says determine algebraically whether f of x equals x plus 3 squared is even, odd, or neither. So I'm going to do f of negative x, and that's going to give me negative x plus 3 squared. And if it's kind of hard to tell, so I'm going to actually FOIL out both of these, or multiply those out. So that's x plus 3 times x plus 3 versus negative x plus 3 times negative x plus 3. In this case, I get x squared plus 6x plus 9. And in this case, I get x squared minus 6x plus 9. So it is neither, because all my signs didn't change, and then all of them also didn't stay the same. We're going to do it again for x squared minus 3, absolute value. So I'm going to do f of negative x, and I get negative x squared minus 3 with my absolute value signs. This negative x squared is the same as positive x squared, and so this is even because I ended up with what I started with. Last one is the following relation symmetric with respect to the x-axis, y-axis, or origin. If it is symmetric with respect to the x-axis, then when I change my y to negative y, I should end up with the same thing. Negative y squared is still positive y squared, and so this is symmetric with respect to the x-axis. In this case, for the y-axis, I would have to do negative x. I can't do anything with this, it's not the same. So this is not symmetric. No symmetry here. And then if I check my origin, I would change both. So negative x and negative y squared. The negative x stays the same. The y can change back. I'm sorry, negative x stays negative x. Negative y squared is positive y squared, but it's not what I started with, so again, there's no symmetry. So my answer is only with the x-axis.